Welcome to 5-Minute Math. This is Carrie Rhinehart. Today I'm going to be looking at complex fractions. This is from Algebra 1, Unit 6, Lesson 8. So a complex fraction is a fraction with a fraction. So you've got a fraction over a fraction. You've got several fractions going on here. For example, if I had x over 2 all over x squared over 5. Now, if you've got this type of complex fraction, this is more of a simple complex fraction, I would just go ahead and rewrite it like this: x over 2 divided by x squared over 5. Okay. Now, since they're both, you only have monomials, you don't have any binomials going on here, you're dividing, so you don't have to worry about common denominators. I'm going to go ahead and keep it, change it, flip it. So we keep the first fraction, change to multiplication, and then flip that second fraction. So now I'm working with x over 2 times 5 over x squared. And again, these are just monomials, so I can cancel out common factors. If it makes it a little bit easier, you could write it as x over 2 times 5 over x times x. So I can cancel one of these x's here, common factor, and that's all I can cancel. So we're left with a 5 on top and then a 2 times x, or a 2x in the denominator. So our final answer would just be 5 over 2x. All right, let's look at one that's a little bit more complicated. So let's say that we have 3 over x plus x over 5 all over x squared over 3 minus 2 over x. Okay, so what I'm going to do first before I rewrite this is I want this to be one fraction, and I want this to be one fraction. And then we can do it like the previous one. But in order to get this 3 over x plus x over 5 to be one fraction, I've got to get a common denominator. So I'm just going to work with this one first. The denominator of 3 over x is x, and the denominator of x over 5 is just 5. I can't factor anything out. They don't have anything in common. So I need to multiply the 3 over x by 5, because I need to have 5 in both denominators since it's in the other one. And then the x over 5, I need an x in the denominator there since it's in the other fraction. So I need to multiply that by x over x. So I end up with 15 over 5x plus x squared over 5x, which is nice because now we've got a common denominator. And I can just write 15 plus x squared over 5x. Okay, so that's our numerator for our complex fraction. Now I need to do the same thing for our denominator. So I've got x squared over 3 minus 2 over x. Well, we need to multiply this one by x over x because we've got an x over here. We need that in the denominator. And the other one needs a 3 in the denominator. So remember, what you do to the top, you have to do the bottom, and vice versa. So when I multiply that, I get x cubed over 3x minus 6 over 3x, which is what we want. We want a common denominator. So now I can simply write x cubed minus 6 over 3x, and that's our denominator. So now I can rewrite this whole complex fraction. I can rewrite this as 15 plus x squared over 5x all over x cubed minus 6 over 3x. And now this is the part where I'm going to do it like the first one. I'm going to write 15 plus x squared over 5x divided by x cubed minus 6 over 3x. And then I'm going to keep it, change it, flip it. So I'm going to keep my first fraction, 15 plus x squared over 5x, times, and then flip this one, 3x over x cubed minus 6. All right, so I could try to factor this stuff, but 15 plus x squared, that's not a difference of two squares. It's not a sum of two squares. There's nothing I can think of that it would factor into. And then same thing with x squared minus 3. There's nothing I can think of that it'll factor into. Now I can cancel those x's. So I have a 3 times this on top. So I'm going to write 3 times 15 plus x squared, or x squared plus 15. Order doesn't matter with addition. Over 5 times x cubed minus 6. And then we are done.